So don't worry about these too much. They are quite difficult. You'd be good to get them, and hopefully you will get them. But they take a bit of practice to spot where the patterns are. Okay. So question 5, page 24. Factorize 2a by x minus 2y minus something 1 by x minus 2y. There's a 1 there, you can't see it. Well, you have your common factor, that's there, and you've 2a minus 1 there. That's that expression factorized. What about 3x squared minus 3xz plus 4xy minus 4yz? Well, let's try and pair off the numbers. Let's say the 3's look good together and the 4's look good together. Okay, if that's the case, what's common. Let's tease out 3x, and 3x squared divided by 3x is x, 3xz is that, and then here we'll tease out 4y, that appears to be common in both, 4y, and then 4xy divided by 4y is x minus z. So our factors are 3x plus 4y and x minus z. Here we have 8xy plus 4ay minus 6bx minus 3by. So just try and pair off the numbers. 8 and 4. 4 divides into 8 and 3 goes into 6. So we'll start with those. We might be wrong. We'll see what happens. So what's common in here? It's 4a times 2x plus y. That's another way of writing 8ax plus 4ay is like that. And what's common here, if we tease out the factors of that statement, it's minus 3b into 2x plus y. So we've 2x plus y, 2x plus y. You basically, in all of these, once you have one factor here, you see what it takes to make the other factor the same there. One factor here, what does it take to make x minus z? What's multiplied by this by this to give that expression? That's another way of kind of looking at it. So here, our factors for question 15 are 4a minus 3b, and 2x plus y. Question 20. 7y squared minus 21by plus 2ay minus 6ab. So let's pair off 7 and 21 because it goes into that 3 times, and 2 goes into 6 and happens to go in 3 times 2, but at least it divides into it. So what's common in this statement is 7y, and divide this and this by 7y, you get y minus 3b. So we're hoping that we've y minus 3b here. So how do we make that look like y minus 3b? Well, if we multiply 2a by that, we get this. Or in other words, 2a is the number we teased out here. Okay. Question 25. 6a squared plus 15xy minus 10ay minus 9. 5 goes into that, 5 goes into that. I think they're a pair. And 3 goes into 9 and goes into 6. I think they're a pair too. Okay, so I'll rewrite that. I'll bring this over here and I'll have 6a squared minus 9ax, 15xy minus 10xy. And basically I will tease out 3a from both of these and divide both of these by 3a to get that. That's what I'm going to be looking for over here. How do I turn that into that? Well, if I take out 5x, I'll get that. So 3a minus 5y, is one factor, and 2a minus 3x is the other. So that's factorizing by grouping terms. Let's look at now factorizing via difference of squares. And I have a formula here. It's a little bit different to the book, but I think it kind of tells us more about what's going on. If I have an expression, a number x squared minus another number y squared, then the factors of that will always be equal to the square root of the number by the square root of x squared, which is x, plus the square root of this number here by the square root of that, which is y. And it's the same factor here, but it's just with a minus sign there. Okay, by example we'll do something. Okay, so 9, factorize 9, that is called via the difference of two squares. So the factors will always be two factors, plus, minus. If there's an x and a y, there'll be an x and a y there. And if there's a number, it'll be the square root of whatever the numbers are involved. So 9x squared minus y squared. So that's the same as the square root is, we'll have two sets of factors, plus, plus, minus, always be an x, because there's an x and a y, x and y, and then The numerical value coefficient of the x is the square root of this, which is 3, and 3, and the numerical value coefficient of the y is the square root of here, which is 1, which is just 1. 25a squared minus 81b squared, well, that's going to be square root, that's 5a plus square root, that's 9b times the 5a minus 9b. X squared y squared minus 4a squared b squared, square root of that is xy, square root of 4 is 2, square root of a squared b squared is ab, same again but with a minus sign. 12x squared minus 70y squared. So now, can't we get the square root of 12 to handy, or 75, but if we look closer we'll see that that's the same as 3 times 4x squared minus 25y squared. Now we have this in a workable form. We can get the square root of 4 and the square root of 5. So the factors are 3 times 2x plus 5y and times 2x, minus 5y, that should be. 2x plus 5y, 2x minus 5y. They'll always be in the form plus and minus, always. And this will always be minus in all these problems. Okay? What about 51 squared minus 49 squared? Well, that's 51 plus 49 times 51 minus 49. That's 100 times 2. It's 200. And from page 26, question 5, 4x squared minus y squared. Square root of 4 is 2x plus y by 2x minus y. 16x squared minus 25 is 4x plus 5 by 4x minus 5. 1 minus 81y squared. Square root of 1 is 1 plus 9y, 1 minus 9y. And then x squared y squared minus 16 is xy plus the square root of that, which is 4, and xy minus square root of that is 4. So 81, h squared k squared minus 25 p squared q squared. Well, that's hk is the square root of that, pq square root of that, 5, 9. So it's 9hk plus 5pq by 9hk minus 5pq. 45k squared minus 20. So we can't get the square root of that, so we have to be clever now and divide 5 into that. So we have 5 by 9k squared minus 4. Now we can work with this because square root of 9 is 3, square root of that is 2, square root of that is k. So it's 3k plus 2, 3k minus 2, all by 5. And we have 4a squared x squared, well that's ax, minus 36y squared is 6y and 2y. Oh no, we can't get the... Can we... Let's see. Yes, we can, sorry. Okay, so yeah, we can divide 4 into both expressions here. Okay, sorry. 4 into both expressions, so that's 4, gives you ax squared, 4 into 36 minus 9y squared, so that's ax plus 3y and ax minus 3y. So they are the factors there. That's part VI. But you know, you can also, that kind of, while I was stalling there, why I was stalling, because you know, the square root of that is 2, square root of 36 is 6. So we could have just said 2ax minus 6y and 2ax plus 6y, but I'm not going to go there. There's two ways of doing that. Okay. So what about this 7.9 squared minus 2.1 squared? Well, the square root of that is 7.9 plus 2.1 square root of that times 7.9 minus 2.1, and that is whatever that is. And here then we have simplify and factorize. Sorry, get rid of this junk. Simplify and factorize. 3x minus 2y all squared minus y by 5y minus 12x. So you'll have to multiply those out together and multiply that as well, and then rewrite all that line, look for what cancels, and you'll end up with 9x squared minus 1y squared, which is the same as 3x plus y, 3x minus y when it's factorized. Now let's move on to factorizing quadratic expressions. So a quadratic expression, it takes the form ax squared plus bx plus c. These are numbers. We're looking to find the factors of quadratic expressions. Okay. So let's have a look at this example. It's not a great example to start with, but anyway, we'll see how we go. So factorize 3x squared plus 10x plus 8. Okay, the first thing to say is this will always, quadratic equation will always have two factors. There'll be something times x plus or minus a number, and something times x plus or minus another number. Okay, and the way we do this is we write our quadratic equation, or expression, sorry, and underneath the 3x squared we write the factors of 3x squared, like 3x and 1x. 3x times 1x is 3x squared. Under this side on the right, this term, we write the factors of this term of 8, and we could say 8 and 1, but we'll go with 4 and 2. Okay. The idea is that we're trying to make this number here by cross multiplying these two and getting 6x, and multiplying those two and getting 4x, and adding plus 6x and plus 4x is 10x. That's what we're looking for. That's what we've got. So these are the factors, 3x plus 4 and 1x plus 2. Okay? So how do we know? How did we know how to do that? Let's see. How do we know how to do that? Well, the cross multiplying is the way to do it, and it's kind of by trial and error, and we'll meet with more of these examples now in the next video.